Hey kids, this is Miss Merriweather, and we are going to fill out our foldable on function, non-function, and relation tonight. Oh yeah, there's Tardy Bell. Okay. First, you need to copy all this down. So pause the video and copy this down. Now that you have the bottom part copied down, you now need to copy down this top part somewhere on your paper. I know different teachers had y'all glue in the graphs and tables in different places, so just try to find room to copy this down inside your foldable. Okay, now that you have this copied down, we're going to talk about it. So definition-wise, it says a function is a relationship in which every input has only one output. I put in parentheses here that x is your input and y is your output. An easy way to remember a function is just that the x does not repeat itself. And we should have covered that in class today, so hopefully y'all remember that. Now if you look here at the asterisk or the star, it says if x does not repeat, look at your y values. The reason that is important, because if your y's are the same, so if you look here at this example, you have 2, 3, and 2, 3. Yes, your x repeats, but your y values are still the same, so that is still a function. If you look over here, the x's repeat, but your y values are different. That is not a function. So make sure you know the difference. So now we're going to go back to covering our tables and our graphs and what we glued in. So first one we're going to look at, the top one is all going to represent a function. So again, if you look at your graph, if you did your vertical line test, which means you drew lines, vertical lines through each part of the graph, it would only touch the graph at one point at a time. So if I drew vertical lines, it would only touch at one point at a time. That is an example of a function. If you look at your table, notice none of these x values here repeat. That is also an example of a function. If you come to your mapping, if you were to connect the x value with the appropriate y value based on your table, so -3 would go to -2, -2 would go to -1, -1 would go to 0, 0 to 1, 1 to 2, 2 to 3, and 3 to 4, you notice not one of these x values have two lines coming from it. That again is a function. And then ordered pair, if y'all don't understand what mapping is just following the arrows and writing out ordered pairs. So -3 is paired with -2. So that would be your ordered pair. Then -2 is paired with -1. -1 is paired with 0. 0 is paired with 1. 1 is paired with 2. 2 is paired with 3. And 3 with 4. If you look again at your x values, do any of them repeat? If your answer is no, then that is a function. Moving down to the bottom part, if you were to draw a vertical line through any of these points, if it touches at two places, that is a non-function because these represent two of the same x values. So if you look at your table, do any of these x values repeat? Yes, they do. So then we look at our y values. Well, -2 goes with 3 and -2 goes with -3. These two numbers are different. Therefore, it is not a function. Moving on to mapping. Again, you would pair them. -2 goes with 3 and -2 goes with -3. -1 goes with 4. And -1 goes with -4. 0 goes with 5. And 0 goes with -5. And 1 goes with 6. If you notice at -2 there are two lines coming from the negative 2. Same thing with negative 1 and 0. Therefore, it is not a function. And if you wrote out your ordered pairs, negative 2, 3, negative 2, negative 3, negative 1, 4, negative 1, negative 4, 0, 5, 0, negative 5, and 1, 6, you would also notice your x's repeat. Therefore, it is not a function. Hopefully you got all this copied down. See you in class tomorrow. Bye.